sketch a graph of this equation. So now we're graphing an equation that has a center that's not at the origin. Do you see what we have up here? This and this mean that the center is not at the origin. It's somewhere else. And in particular, you remember how this worked for ellipses. It's the same thing here. It's opposite, opposite. So the center of this is hyperbola because it has minus in the middle, right? So the center of this hyperbola must be opposite of plus 3, minus 3. X always has to come first, right? And then opposite of minus 1, plus 1 for y. So back 3, up 1. Boom, right there. Back 3, up 1. That must be the center of this hyperbola. Opposite, opposite. Okay. Now that we have that, we need to find out how big to make the dotted box. Whatever's underneath y, rewrite that as 3 squared. That's up and down. So I'll go up 3 and down 3. See what I did there? I went up 3 and down 3. Because whatever's underneath y is always up and down. Oops. This is up, down, 3. And now what's underneath x? Well, there's nothing. Well, that's the same thing as 1, or if you want, 1 squared, right? So if it has no denominator, it really has a 1, because dividing by 1 doesn't change anything. Do you know what I mean by that? If I write 7, that's not any different than 7 divided by 1, is it? 1 goes into 7 times. Remember, a fraction means divide, like 10 divided by 2 is 5, because 2 goes into 10 5 times. 1 goes into 7 times. So anytime you have a whole number, you can always put it over 1 and you haven't changed anything. So we need to see a denominator, because that tells us how far right and left to go, but we can't change the problem. So we put it over 1 squared, which doesn't change anything, and yet gives us a denominator. So it's really over 1 squared, and that is the right-left amount. So it goes right 1 and left 1. So there is our dotted box. Let me put it in there for us. So from the center, the box goes up and down 3, right and left 1, because that's what's underneath y. Up and down 3, and underneath x, an invisible 1 squared, right and left 1. Okay, and then we let the diagonals go through the corners, right? The asymptote lines go from the center through these 4 corners, and then they keep on going right through this corner and this corner. Just like that. Beautiful. Okay, so now we have the diagonals. Now it's time to make the graph. How do we actually make this graph? Well, the branches, are they going to go, how do we know if they're right, left branches? That's when you have x squared in the front. The branches go right, left. If you have y squared in the front, remember, the branches go up and down. We have y squared. The front is y squared, so the branches are going up and down. So it starts from the middle of the box, branch going up, and it gets really close to those asymptote lines. Those are the guidelines, tell you how wide or narrow the branch is open. Up and down forever. There we go. There's the graph of the hyperbola. Now, to do it on the graphing system in the homework system, what you have to click 2 things. You have to click the center of the box at back 3, up 1, and the upper right-hand corner of the box. And then that frames the box, which frames the diagonal asymptote lines and puts in the branches and everything. So just the middle of the box, which is at -3, 1, and then from there you have to go right 1, up 3, because right 1, up 3 is what's underneath x and y. Let's see it. So here we go. So I'm going to use the controls at the bottom. So first off, I got to select the right controller. See these controllers? This is making a circle, making an ellipse, making branches up and down, making branches right and left. What do we have? This one, up and down branches. So I click on the up and down branch. See me down here clicking on these different tools? I'm going to go with this one, which is up and down branches. The center is back 3, up 1, so I click on that center. It's my first dot. My next dot is the upper right-hand corner, which is right from that center, is from that red dot, is right 1, up 3. There we go. See how it puts in the box, the frame, everything. There is the graph of our hyperbola. Centered at back 3, up 1, and the box is right 1, up 3. Between the red dots, it's right 1, up 3, because that's what's invisibly underneath x and y, 1 squared and 3 squared. So there we go.